Welcome back to the drive-thru. Today we're going to do practice with CPCTC, which stands for corresponding parts of congruent triangles are congruent. So it's important to remember what that abbreviation stands for, because that's going to tell us how we're allowed to use it. So we have 3 steps when we're using CPCTC. First, we need to prove that 2 triangles are actually congruent. So we have 3 postulates so far on how to do this. So this is our side, 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 angle, side, or angle, side, angle. Those are the 3 ways that we can prove 2 triangles are congruent. So first we want to make sure that we're using one of those postulates to prove 2 triangles congruent. After that, we want to identify corresponding parts of those triangles. So we want to find 2 angles or 2 segments that are the same in both triangles. And then CPCTC allows us to prove those 2 triangles are congruent. So those are our 3 steps. We're going to practice those in a couple examples. So first we're going to start with an easier one. So I'm going to set up our proof. And we know we always want to start our proofs by listing out our givens. So our first step, I'm just going to copy down the information that it gives me. So segment AB is congruent to DE. BC is congruent to EF. And AC is congruent to DF. So now I'm going to take those givens and label them how we know it on the triangle. So if AB is congruent to DE, I'm going to use our tick marks. Then BC is congruent to EF. And lastly, AC is congruent to DF. So that just helps me see what we actually know. Now, going back to those 3 steps we had earlier, the first thing we needed to do was prove those 2 triangles congruent. So I can say that triangle ABC is congruent to triangle DEF by side, side, side. So that was one of those 3 postulates we have, and we were given that all 3 sides are congruent, so we know the 2 triangles are congruent. So now we know that we need to prove that angle A is congruent to angle D. So if we're looking back at our pictures, this angle A and angle D are corresponding parts because they're both in between the sides that are congruent. We know AB was congruent to DE and AC was congruent to DF, and A and D are those angles in between those 2 congruent sides. So if those are corresponding parts, then I can say angle A is congruent to angle D by CPCTC. They were corresponding parts of congruent triangles, so they must be congruent. Let's try a little bit of a harder example now. So setting up our proof, and again we're going to start with our given. So our given just says that P is a circle. That's what that notation stands for. So in this section we've used some of what it means to be a circle. So if P is the center of that circle, we want to see any radii that we can find. So a radii is just any segment that goes from the center of the circle to the outside of the circle. So we see PC is a radii. So is PD, PA, and PB. If those are all radii of the circle, they have to be congruent. So I'm going to say all 4 of those segments are congruent because all radii are congruent. And then I'm also going to mark that in our diagram so that we know we've stated it in our proof. Now, we know we needed to prove that 2 triangles were congruent, so we have some information, but we also need to list something else out before we can use our postulate. So if we're thinking back to our side, 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 angle, side, or angle, side, angle, we already have 2 sides that we know, so we might be able to guess that we want to use side, angle, side here. And if we wanted to use that one, we need that included angle between the sides. So I need to say that angle CPD is congruent to angle BPA. And I'm allowed to do that because those are vertical angles. And vertical angles have to be congruent. So now we see from a picture we have a side, an included angle, and our other side in both triangles. So I can say the triangles are congruent. So if we're listing those in the right order, we're going to have triangle CPD is congruent to triangle BPA. And like we said, those are congruent as side angle side. Now, the conclusion we wanted to do in this proof was that AB is congruent to CD. So if we look back at our picture, segment AB and CD are corresponding parts of these triangles. So that means we can use CPCTC to state that they are congruent. We proved our triangle is congruent, then we can say our corresponding parts are congruent. Okay, so one last example here. Again, setting up our proof and listing our givens out. So triangle HGJ is congruent to angle HGJ is congruent to angle KJG. So I'm going to mark that. So HGJ, we know G has to be our vertex, so we have that angle. And that's congruent to angle KJG. So there's that angle there. We also had the given that KGJ was congruent to angle HJG. So if I draw those in two, we have angle KGJ. So I'm going to use two lines there to make it different from the other angle. And that's congruent to angle HJG. So this angle here. Those were our two givens. Now, I know I need to prove these two triangles congruent, so we want to think through which postulates we're allowed to use. We have side, 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 side angle, side, or angle, side, angle. But we already know two angles that are congruent. So that's a good hint that we're probably going to need to use angle, side, angle. But that means we need to figure out some side that we also know is congruent in two triangles. So if we're doing angle, side, angle, we need two angles and the side in between them. So looking up at this picture, that means we're going to need that side JG is congruent to JG, because that's part of both triangles, and it's in between those two angles we already know. So I'm going to say segment GJ is congruent to itself, and that's our reflexive property. So now I've listed out the three things I know. So I've already listed out my angle, my side, and my angle. So I can say triangle GKJ is congruent to triangle JHG. We're making sure we're listing those vertices in the same order in both triangles. And that we know by angle, side, angle. So now that I've listed those, said that those two triangles are congruent, segment HG is a corresponding part to side KJ. Like if we look back in our congruence statement up here, KJ and HG are listed in the same order, so they're corresponding parts. So we can say HG is congruent to KJ by CPCTC. And we finished our proof.